Right now, at this exact moment, a 375-meter asteroid is traveling through space on a collision course with history. Not with Earth. That threat was eliminated 2 decades ago. But on April 13th, 2029, something will happen that hasn't occurred in recorded human history. And when it does, it will fundamentally change how billions of people see the night sky. In 3 years, a rock the size of a skyscraper will fly closer to Earth than the satellites sending signals to your television. It will pass so close that roughly 90% of every human being alive on this planet will be able to see it moving across the night sky with nothing but their own eyes. No telescope, no binoculars, just look up. This is the story of Apophis, the god of chaos, and why planetary scientists are calling 2029 the most extraordinary astronomical event in human civilization. This is the moment everything changes. Planetary scientists gathered in Padua, Italy, just this past June 2026, where researchers held the Apophis T-3 years workshop. Researchers assembled from NASA, the European Space Agency, JAXA, and dozens of international institutions made one thing unmistakably clear. This event will be the first time in all of recorded human history that people knew years in advance that an asteroid would be visible to the naked eye passing Earth. The last time anything this large came this close to our planet, there was no one around to record it. There will not be another opportunity like it for longer than human civilization has existed. But here's the part that the headlines rarely explain properly. For a few terrifying weeks in late 2004, scientists genuinely did not know if this rock was going to hit us. The calculations that came back from the first round of orbital modeling showed odds of impact that no asteroid had ever produced before in the entire history of planetary surveillance. And hidden inside those odds was a cosmic trap so precisely engineered by the laws of physics that a miss of just a few hundred meters could have set up a guaranteed second strike 7 years later. That story, and what it means for what is about to happen in April 2029, is what this is actually about. The rock has a name now that fits its history perfectly. It is called Apophis, taken from the ancient Egyptian serpent deity of chaos, the mythological enemy of order and light. But when it was first spotted on June 19, 2004, by 3 astronomers working at Kitt Peak National Observatory in Arizona, it had a purely bureaucratic label, 2004 MN4. The designation follows a standard astronomical naming system that has been in place since 1925, just a filing code that tracks the year of discovery and the order within it. Nobody paying attention to that initial data stream had any reason to think this particular object would matter. It looked like thousands of other faint points of light drifting against the background stars. The first observations were routine, but then the orbital calculations came back and everything changed at once. Within months of discovery, 2004 MN4 had accomplished something no asteroid tracked in modern history had ever done. It reached level 4 on the Torino scale, which is the standardized rating system for asteroid impact risk created by planetary scientist Richard Benzel of MIT in 1999. The Torino scale runs from 0, no concern, to 10, which represents a certain global catastrophe. Level 4 had never been reached before, and as of today in 2026, more than 2 decades later, that record still stands. No other asteroid has ever come close to matching it. Behind that number sat a peak calculated probability of 2.7% that the asteroid would hit Earth on April 13, 2029. For most contexts, 2.7% sounds small, but when you apply those odds to a rock hundreds of meters wide striking a populated planet, the scale of what that number actually means becomes something else entirely. And buried inside that initial impact probability was a second threat that in some ways was even more alarming than the direct impact scenario itself. Astronomers identified what they call a keyhole. A keyhole is a specific, precisely defined region of space, in this case roughly 800 meters wide, smaller than most airport runways, that the asteroid might pass through during the 2029 flyby. The keyhole concept was formalized in the early 2000s by researchers at JPL and the University of Pisa, and it describes a zone where the outcome of a planetary encounter becomes extraordinarily sensitive to the exact path taken. If Apophis threaded that keyhole, Earth's gravity during the 2029 pass would bend its trajectory with surgical precision, setting up a guaranteed return impact in 2036. It was the celestial mechanics equivalent of a butterfly effect. A small shift in position during one encounter, measured in hundreds of meters, producing a completely different planetary outcome years downstream. For a few days at the end of 2004, that scenario was not a theoretical footnote. It was an active concern sitting in the calculation tables of every major planetary defense group in the world. The resolution came quickly and almost accidentally. On December 27, 2004, planetary astronomer Jeff Larson and colleagues working with the Spacewatch Sky Survey dug through older photographic archives and found images of the same object taken on March 15, 2004, months before anyone knew to look for it. In astronomical terminology, this is called a prediscovery, And it matters enormously because the precision of any orbital prediction depends directly on how long a baseline of observations you have to work with. More time between the oldest and newest observations means a tighter, more accurate orbit. With that extra stretch of data added to the calculations, the impact probability collapsed almost entirely, and the keyhole scenario went with it. The asteroid had been given its permanent name by that point, and the name was already sticking. Apophis, the god of chaos. For a brief and genuinely frightening window in late 2004, it had earned that name, and now it was confirmed safe. The immediate threat was eliminated. The story should have ended there. It did not, because what replaced the fear was something that the planetary science community recognized almost immediately as a different kind of extraordinary. Not a threat, an opportunity. An opportunity unlike anything the science of asteroids had ever been handed before. The 2021 radar campaign settled the safety question permanently. NASA's Goldstone Deep Space Communications Complex in California and the Green Bank Telescope in West Virginia bounced radio signals off Apophis from a distance of roughly 17 million kilometers and refined its orbit to a precision that ruled out any possibility of Earth impact for at least the next 100 years. NASA's Sentry Impact Monitoring System formally removed Apophis from its risk table. The last lingering concern, a potential impact scenario in 2068 that had remained technically open, was eliminated by the radar data. The orbital uncertainty code for Apophis now sits at 0, the most confident designation the system awards. That particular asteroid is not going to hit us. But what it is going to do is almost as remarkable in its own way. On April 13th, 2029, a date that happens to fall on Friday the 13th, Apophis will pass within approximately 30 to 32,000 kilometers of Earth's surface. To put that distance in context, the ring of geostationary satellites that orbit Earth at an altitude of roughly 36,000 kilometers, the communication and weather satellites that ground stations track continuously, sits farther out than Apophis will come. This asteroid is going to pass inside the zone where we park our most important space infrastructure. It will briefly be deeper in Earth's gravitational field than most of our own satellites. For scale, it will pass at roughly 1/10 the distance to the Moon. Events of this kind, an object this large coming this close to Earth, happen on statistical timescales of 5,000 to 10,000 years. The previous time, something comparable occurred. Written records did not exist. The next time, something comparable will happen after 2029. Our current civilization will likely not exist in any recognizable form. But this is a once in 10,000 years astronomical event. And for the first time in human history, we knew about it years in advance, and we have spacecraft ready to be there when it happens. The visibility picture alone makes this unlike anything that has ever been publicly documented. Scientists presenting at the June 2026 Apophis workshop at the University of Padua shared detailed maps showing that up to 90% of Earth's population will be within the geographic zone, where Apophis will be visible at some point during its roughly 7-hour flyby window. The regions of best visibility during closest approach are Europe, Africa, and parts of Western Asia and the Middle East. At its peak brightness, Apophis is expected to shine at approximately second magnitude, which puts it roughly in the same visual brightness range as the stars of the Big Dipper. This will not be a fleeting streak across the sky like a meteor burning up in the atmosphere. Apophis will appear as a steady point of light moving slowly and visibly across the sky over hours, fast enough that watchers can see the motion in real time, but slow enough to track comfortably without any optical aid. Richard Benzel, the planetary scientist who created the Torino scale and who opened the Padua workshop, reportedly delivered his opening remarks with a pointed emphasis. Apophis will safely pass the Earth. Apophis will safely pass the Earth. Apophis will safely pass the Earth. He said it 3 times, not because the audience needed convincing of the science, but because the history of this asteroid and the cultural weight of its name made it necessary to establish the ground truth clearly before proceeding to everything else. And the everything else is where the genuine scientific drama lives, because Apophis is not a simple, boring, solid sphere of rock gliding past on a clean and predictable path. Everything that 20-plus years of radar imaging, light curve analysis, and orbital tracking has revealed about this object describes something considerably stranger. Start with the shape. Radar measurements, using the technique called delay Doppler imaging, which works by bouncing radio signals off the asteroid and measuring both how long the echoes take to return and how their frequency shifts, have produced a silhouette that does not resolve cleanly as one continuous body. The returns come back looking like 2 separate lobes connected at a narrow, constricted middle, like 2 mismatched stones that drifted toward each other through the ancient history of the solar system, touched at a single point, and have been held together ever since by nothing stronger than their own mutual gravity. This is what astronomers call a contact binary structure. The asteroid Itokawa, which Japan's Hayabusa mission actually landed on in 2005, has the same characteristic two-lobed appearance. So does Arrokoth, the distant Kuiper Belt object that NASA's New Horizons spacecraft flew past beyond Pluto. In January 2019, a body so obviously composed of two distinct pieces fused together that scientists informally called it a cosmic snowman before the detailed analysis was complete. If Apophis belongs in the same structural family, it is not one rock at all. It is two, held together at a narrow neck by gravity and whatever weak cohesion formed when they first made contact. The critical uncertainty is that current radar resolution cannot definitively distinguish between a genuine two-lobed contact binary and a single piece of rock that is simply deeply concave in the middle, pinched dramatically enough to produce the same radar silhouette. No observer on Earth right now can rule either picture out with certainty. And that uncertainty matters far more than it might initially seem, because a body built like that, whether it is genuinely two pieces or one body with a structural weak point at a narrow waist, does not respond to external forces the way a solid, uniform sphere of rock would. And in 2029, Apophis is going to be subjected to forces it has not experienced in a very long time, possibly not ever in its current configuration. Then there's the rotation, which adds another layer of complexity that makes the 2029 encounter genuinely difficult to predict in its details. Most asteroids spin the way a well-thrown football moves through the air, rotating cleanly around one stable axis, predictable and steady. Apophis does not do this. Radar and light curve data reveal that Apophis tumbles, which is a completely different type of motion. Instead of a clean, single-axis spin, it wobbles simultaneously around more than one axis at the same time. So its orientation drifts through a slow and complicated loop, rather than repeating the same simple turn over and over. Physicists recognize this as non-principal axis rotation, and it is the rotational equivalent of flipping a book end over end through the air instead of spinning it flat. For Apophis, specifically, this tumble plays out across two overlapping cycles simultaneously. One cycle runs approximately 264 hours, longer than 11 full days. A shorter cycle runs roughly 27 hours, just over one Earth day. Both of those sit on top of an underlying rotation period near 31 hours. Three separate rhythms, unsynchronized, all running at the same time. That kind of complex tumble does not appear from nowhere. Something knocked Apophis out of clean rotation at some point. Likely an old collision with another object, an uneven internal mass distribution, or a past close planetary encounter. And once a small body begins that kind of wobble, there is typically nothing internal strong enough to dampen it back out. The tumble persists, sometimes for millions of years, encoded in the asteroid's rotation, the way an old injury can outlast the impact that caused it. In 2029, Earth's gravity is going to grab that already unstable tumble and pull on it. The side of Apophis facing Earth during closest approach gets tugged toward our planet more strongly than the far side. That imbalance, the same basic mechanism that raises ocean tides on Earth, creates a stretching and squeezing force across the asteroid's entire body. Scientific modeling published in the research literature predicts this tidal interaction could dramatically alter Apophis's existing tumble, with its effective spin rate potentially halving or doubling, and the direction its rotation axis points shifting by 10 degrees or more. These predictions were studied extensively in a detailed spin state analysis that examined thousands of simulated scenarios, accounting for the uncertainties in the asteroid's mass distribution and current rotational parameters. The range of outcomes is wide, but the consensus is that the changes will be real and measurable. Telescopes back on Earth are expected to detect the shift in real time, watching an asteroid spin get rewritten by the gravitational pull of our own planet during a single 7-hour window. What happens to the surface during this gravitational reshaping is a related question that carries its own uncertainties. Research into tidal resurfacing models for the 2029 encounter suggests that wholesale dramatic surface collapse is unlikely because Apophis passes at approximately 6 Earth radii from our center, which keeps it outside the classical zone where tidal forces can completely restructure a loosely bound body. But smaller surface changes remain entirely plausible. Loose materials sliding on slopes that were already sitting at the edge of stability, localized rock shifts, and minor avalanches are all within the realm of possibility. A 2026 refinement to the modeling added a careful caveat. The actual degree of interior change may end up more limited than earlier estimates suggested, but this depends on structural details of the asteroid that nobody has yet confirmed from direct observation. The honest answer is that the real test is still ahead, and that is precisely why 2 spacecraft from 2 different space agencies are being sent to be there when it happens. The European Space Agency's mission is called RAMSES, which stands for Rapid Apophis Mission for Space Safety. RAMSES received full funding approval at ESA's Ministerial Council meeting in late 2025, clearing the critical political and financial hurdle that moved it from planning into actual construction. The mission must launch by early 2028 to intercept Apophis in open space before the flyby. The prime contract was awarded to OB Italia, and Japan's space agency JAXA signed on as a partner, contributing a thermal infrared imaging package drawing on their experience with the Hayabusa 2 mission. Ramses is scheduled to arrive at Apophis in February 2029, 2 full months before Earth's closest approach, and then simply stay with it, matching its speed and following its path through space so closely that the two of them effectively travel together for months. This is what engineers call a rendezvous. The timing is the entire scientific point. Ramses measures everything about Apophis as it exists before Earth's gravity has touched it at all. Its shape, its tumble, its surface texture, its density distribution, its thermal properties. Then it watches everything potentially change in real time during the flyby. Nobody has ever had instruments positioned to watch an asteroid encounter unfold from alongside the asteroid itself. Ramses will be the first. The second spacecraft arrives from the other direction. OSIRIS-APEX is the same probe that spent years orbiting the asteroid Bennu, collected a pristine surface sample, and delivered that sample capsule safely back to Earth in September 2023. Instead of being retired after completing that primary mission, NASA renamed it OSIRIS-APEX and redirected it toward Apophis under a new principal investigator. OSIRIS-APEX is scheduled to arrive at Apophis shortly after closest approach in April 2029, conduct an initial flyby, and then settle into extended operations around the asteroid for the following 18 months. One of its most distinctive planned activities involves firing its own thrusters directly at the asteroid's surface from close range, not to damage or deflect anything, but to kick up loose surface material. The same way blowing hard across a dusty table reveals what is underneath. This allows scientists to examine what lies just below Apophis's outer surface layer, a technique that OSIRIS-REx already demonstrated productively at Bennu, where the sample collection attempt revealed a surface so weakly bound that the spacecraft nearly disappeared into it, a direct physical confirmation that Bennu was a loosely packed rubble pile. There is also a third mission element. Japan's Destiny Plus spacecraft, originally aimed at asteroid Phaeton, has trajectory adjustments that will allow it to swing by Apophis as well, adding additional observational perspectives to what is already the most comprehensively instrumented asteroid encounter ever planned. Line these missions up together, and what you get is genuinely unprecedented in the history of planetary science. One spacecraft watching the asteroid before the encounter in full detail. The asteroid then passing through Earth's gravitational field, while ground-based telescopes around the planet track everything measurable from the surface. Then multiple spacecraft examining the aftermath in close proximity for months afterward. It is a natural before and after experiment on a body that Earth's own gravity is about to stress test. And nobody had to design or engineer the experiment. Nature scheduled it, the physics of orbital mechanics delivered it, and the only thing the scientific community had to do was show up with instruments ready. But what makes this moment even more significant is what it represents for humanity as a whole. For millennia, we looked at the night sky and saw what we wanted to see. Patterns, myths, messages from the gods. Then, roughly 400 years ago, we built telescopes and started learning what the night sky actually contains. Stars, galaxies, billions of other worlds. We learned that we are not the center of anything, that our planet is ordinary, that objects far larger than anything we have built can approach from the darkness without warning. For most of human history, that knowledge was abstract. It did not touch us personally. We read about asteroids in news articles. We watched documentaries. We carried on with our lives. But Apophis is different. Apophis is about to make the abstract concrete. On April the 13th, 2029, a person standing in Europe at twilight will be able to point upward and say to the person beside them, "That thing right there? That is a rock the size of a building passing closer than our satellites." A farmer in Africa will step outside and see it cross the sky and know that they are witnessing something that nobody alive today will ever see again. A child in Asia will look up and have a memory burned into their mind that will stay with them for the rest of their lives. This is the significance of what is about to happen. Not the science, though the science is extraordinary. Not the spacecraft missions, though those are unprecedented. But the moment when humanity collectively looks up at the same time and shares a common experience that transcends borders, cultures, and languages. Every specific prediction covered in this story has an expiration date. The possible two-lobe structure, the halved or doubled spin rate, the potential surface slides on unstable slopes, the reshaping of the orbit from an Aten class to an Apollo class asteroid. All of it will be either confirmed or disproved by April 2029. Up to 90% of the humans on Earth will be able to look up and see Apophis moving across the sky with their own eyes. A shared observational experience that no asteroid has ever provided before in the entirety of recorded history. 2 spacecraft will be there with instruments capturing what human eyes cannot. The god of chaos, named in 2004 during days when nobody was sure if it was going to destroy a city or miss entirely, is arriving on schedule. And this time, instead of dreading it, the entire planet is ready to witness it. In 3 years, something is going to happen that will change how we see ourselves in the universe. It is already in motion. The countdown has already begun. And when that night arrives, when you look up and see that steady point of light moving slowly across the darkness, you will be standing on a planet with billions of other people, all looking up at the same moment, all witnessing the same astronomical event, all aware that they are seeing something that has not been seen in recorded human history. That is the story of Apophis. That is what is about to happen. That is why, right now, at this exact moment, everything is ready. The god of chaos has an appointment with Earth, and this time we are ready to keep it.